Great. Good morning. My name is Robert Watson. I'm going to be talking to you this morning about how a large-scale open source project works. Before I get started, I'll tell you a little bit about my background. Before I came to the open source community, I actually lived in the shareware community in about the early 1990s. My first experience with dealing with somebody else's large-scale open source project, or at least shareware project, was the World War IV BBS software, which was shareware that had the somewhat interesting and unique property that if you registered it, the author, Wayne Bell, sent you the source code in C. And this was a very enlightening experience. It was a very large piece of software. But one of the things that happened with World War IV is that a community built up around the software where people distributed patches or mods, modifications. And these could be anything from cosmetic changes in the software to quite large-scale infrastructural changes. And that community resembles a lot, in many ways, the open source communities that we have today. And a couple of years later, in about 1994, I discovered my first Unix system, and I realized that actually that was what I had been looking for. It had context switching, it had processes, it had all this cool stuff that didn't exist in MS-DOS, but it was open source, which is quite a neat place to be. So my background is that I started out using Unix systems in about 1994. I got involved in DARPA research and development in the US, operating system security research. And for that, we used FreeBSD and Linux, and later on, Mac OS X, as Darwin became open source. And open source really transformed the way that we did research. And so I got more involved, in particular, in the FreeBSD community. So what I'm going to do today is talk to you a little about how you structure an open source project. And I'm going to use FreeBSD as my case study throughout because it's the open source project I'm most familiar with. But I have been involved in other open source projects. I was involved in the Coda file system project at Carnegie Mellon and some others too. I think you'll find that some of the things that I talk about, the themes that I talk about, really recur across a large number of open source projects, and especially large open source projects. I think it's important to begin by talking about what we mean by open source project, because I think there's some confusion on that front. There's a big difference between a piece of software under an open source license and the community that produces that software. And what I'm here to talk about today is the community that produces the software, and not so much the software itself. This is not an operating systems talk. I'm not going to talk to you, at least not in any detail, about kernels, much as I would love to do so. But instead, I'm going to talk to you about the social structures that allow us to build a large-scale operating system over a very long period of time. So I'll tell you about the FreeBSD project up front, but mostly I'll tell you how it works. And I should, of course, preface this by saying I am a kernel developer. They tell me that there are these user applications that exist in user space, the system calls, there's something on the other side of that barrier, but I don't believe it. So this is, of course, entirely from my perspective as a kernel developer. So what is an open source project? An open source project is the social structure around a piece of open source software. And I think we know what open source software means. It simply means software distributed under a license that is considered open. And there are various definitions of that, and FreeBSD certainly falls under that. But the open source project is a lot more. It obviously includes the source code, but typically also the revision history of the source code, which in the case of the FreeBSD project is going on a 30-year software legacy at this point, which is quite a long time. But it involves all the people who write the software, but also the people who document the software, support the software, in many cases use the software, distribute the software, rebundle the software, and hopefully advocate for the software. When the organizers of FOSDEM asked me to give this talk, they were particularly interested in the large-scale aspect. And I had to sit down and think for a minute, what does large-scale mean in the context of an open source project? Well, I think I understand small scale. Small scale is one guy sitting in the basement hacking on code until 2 a.m. every day, or maybe 4 a.m. more optimistically. But what is a large-scale project? I think what makes a project large-scale is not the size of the source code, and FreeBSD is a large software project. But it's the size of the institution around it. It's the fact that it has a sustainable community model, that over time the project keeps going even though people, individuals come and go. You know, the people who founded the FreeBSD project, some of them are still involved, but many of them aren't, and there are many, many new people involved. And I think that's what makes a project scalable. It's the social model being scalable as you move forward. So I'll tell you very briefly about what FreeBSD is, because it provides some of the context for understanding some of the points that I'm going to make. FreeBSD is a BSD Unix. The BSD project, the Berkeley software distribution, was a project at the University of California, Berkeley. It began in the late 1970s. And the FreeBSD project is an open source project that spun off of that in the early 1990s. We do have source code in our tree, which is 20 to 30 years old. We also have a vast quantity of source code that is a lot more recent than that. But it's an interesting software legacy. I think we actually have a heritage of software, and there's an increasing number of projects that are no longer on their first generation developers. Of course, one of the other things that makes the FreeBSD project particularly interesting is that we do have some of the original BSD developers working on the project. We do have people who have been working on our software for 25 years continuously, and that's quite unusual for an open source project. And I'd like to think there will be many more of these projects over time, and that the open source model will keep on working the way it has. But I think it really is a really valuable resource to be able to turn to someone who has been working on the software for longer than some of the people on the project have been alive, to ask them why it is that things are done the way they're done. FreeBSD is very widely used. It's a little bit less visible than some of the other members of the open source community. People don't know as much about FreeBSD as many of the places it's used as they might with Linux, or maybe even something more widespread like Firefox. But it is widely used. You'll find it at many internet service providers around the world. You literally cannot use the internet, for 30 seconds without hitting FreeBSD boxes, from the root name servers to many of the ISPs that host websites to large-scale hosting sites. But also routers on the internet. Juniper routers run JunoS, which is based on FreeBSD. You'll also find things like anti-spam appliances from Cisco. Mac OS X contains significant parts of the FreeBSD kernel and user space. VxWorks, many versions include a FreeBSD-based IP stack. The NetApp operating system runs FreeBSD. Their new version of ONTAP GX uses the FreeBSD kernel and FreeBSD user space along with their own parts, obviously. So you find FreeBSD in a lot of places. FreeBSD is also, thinking back to the previous talk, fairly widely used in the media and entertainment industry. We don't run so many render farms, although the Matrix was rendered on FreeBSD running Linux render-man binaries. But we do run the storage clusters that many of these places use. For example, Technicolor uses a product from Isilon, a storage cluster, to manage their video editing and video processing, and that is based on FreeBSD. Avid, which is also widely used in the media industry for TV editing and video editing, uses a FreeBSD backend for the storage cluster. So you find us in the same sorts of places, although maybe in slightly different kinds of ways. And as I said, it's very difficult to get very far without running into FreeBSD, even if you don't see it. What is FreeBSD? Well, it is a complete integrated Unix system. We have all the good stuff, right? We have the multi-processing, multi-threaded, fully preemptive kernel. We run on a number of hardware platforms. They don't quite run on everything in the world, but those that we do run on, we run on quite well. We provide all the normal programming interfaces. Last I checked, when I did a grep last night, it seemed to be about 17,700 third-party packages. We're also the reference implementation for many network protocols, including SCTP. So we have involvements in the standard community. SCTP is the most recent of these to turn up in our tree. One of the reasons that sites pick FreeBSD, especially to build products on, is that we have a fully unified build system. You type in one command, it builds the whole system using consistent make parts throughout the entire operating system. We also have extensive documentation. So these are, I think, attributes you'll find for many open source projects. They have to try and build the infrastructure to assemble lots of pieces from lots of places. So we produce a lot of software. We also consume a lot of software. And a little later in the talk, I'll show you some of the relationships we have in the open source community that allowed us to build a whole operating system. The FreeBSD project is, of course, distinct from the FreeBSD software. I told you before that I draw a distinction in my mind between open source software and open source projects. The projects are these social institutions that produce software in a sustainable way. FreeBSD project is largely an online community. We have developers scattered around the world, and I'll point at some of them in a little bit. But we center our development on revision control. The FreeBSD CVS repository has 10 years of history going back, and then there are previous CVS repositories and RCS repositories going back into the 1980s. We really live in revision control, and this is not true of all open source projects, but it is increasingly true that revision control is sort of the heart and soul of the project. We really do everything in revision control. We have an online community made up of a great many mailing lists, and I'll talk a little bit more about that. We have 340 CVS committers, and these are people who we grant direct commit access to our source repository. But we also have thousands, literally thousands of active contributors submitting patches on a daily basis. And I'll talk a little bit about the people who are both in our immediate CVS committing community, but also the larger development community. And I think there's a scalability aspect there, both of how you involve people in revision control, but also where you bring in changes from, that is quite interesting. One of the things that does distinguish FreeBSD from, say, Linux is the license. We use the Berkeley license, which is very similar to some of the other licenses, MIT license, the Carnegie Mellon license, and so on. It basically says, please don't sue us. You might consider giving us credit, but really, that's about it. There's no obligation to return your changes to us. What's important about the way we've structured the FreeBSD community is that people return changes even though there is no license obligation to do so. And that's part of what makes these communities successful. And even in communities where you have a license like the GPL, there's a big difference between people making a tarball available on the website of their company, or possibly not making a tarball available on the website of their company, and people bringing the changes back to the community, getting involved and trying to merge the changes back in. And it's the community aspect that's important. I think the license is almost ancillary to the point that if you want to get the changes back into your software, you have to have involvement of the consumers of the system. And so I'll talk about how we convince people to do that and some of the cases where we succeeded. I'll talk briefly about the legal and organizational infrastructure of the project. When the FreeBSD project was first created in the early 1990s, on the whole, open source projects didn't really exist. And those that did exist didn't really have nonprofit foundations associated with them. Today, everybody has a nonprofit foundation. But when the FreeBSD Foundation was created, it wasn't clear what the model was by which you associate a foundation with a project. Is the foundation the same as the project? Is everyone who is a member of the project a member of the board of the foundation or a voting participant of the foundation? Are there legal agreements in place between the foundation and the project? And we made an intentional decision to separate our foundation from our project. One of our concerns was the foundation might become a target for litigation, that people might say, look, FreeBSD, this cool piece of software, hey, there's a foundation, maybe they have some money, we'll sue the foundation. And if you make your foundation separate from your project, that actually means your project can persevere even if your foundation goes away. It also wasn't clear whether there was really all that much use to having a foundation. We wanted an organization to provide some legal guarantees and structure and so on, but it wasn't clear in the long term if people would give a foundation money, for example. It turns out they do give the foundation money. In fact, last year we raised more money than we've raised in any previous year in our history, which is quite nice. But the foundation exists, and it basically operates somewhat independently. There's a lot of communication between the foundation and the project, but we don't, unlike, for example, the Apache Software Foundation, require members of the project to be members of the foundation. So there's an interesting structural setup there. And of course, I should make a plug. Consider giving the FreeBSD Foundation some money, even if you don't use our software. We're really very nice people. What do we produce? Again, the distinction between a project and a piece of software. Obviously, we do produce software. We produce a lot of software, and a lot of people use our software. But software isn't very useful by itself. When we produce a tarball or an ISO image of FreeBSD, we don't just stop there. We continue to support it after we've released the software. We release security updates. We go through an extensive release engineering process. Most releases take 6 to 12 months to actually go through the release engineering process, excluding development. That's the time to go through the testing process, get it deployed and evaluated through betas and alphas and release candidates and so on. We also produce a lot of documentation, and documentation is really key. We have extensive man pages and online web pages. I'll talk a little bit more about that. We also have a community of people who help support the software and debug the software. We have a mailing list you can email with any question you might have about FreeBSD. And probably the more ridiculous the question, the less useful the answer. But there are a lot of useful answers. And there's a community of people who literally just sit on that mailing list answering questions, which is quite important. And finally, we have user events. And I'm pretty pleased to be able to include FOSDEM as an event that FreeBSD participates in. But we have a lot of conferences we're involved in. And I'll talk to you a little bit more about how that happens. We also consume things. Open source software, and even free software, does not happen for free. We have a particular interest in beverages. I think Philip organized an excellent event last night, and obviously we would appreciate more events along those lines. But we do like other things too. We have a particularly tangible interest in donated hardware. We believe firmly that servers belong in racks. Preferably, servers should require multiple racks. We like it particularly when they come with hands, people to help manage the servers. I'll talk to you a little bit about, in a bit, our clusters of machines located around the planet, which are largely donated by organizations who use FreeBSD and also managed by them. And management is very important. Software people, perhaps not always so strong when it comes to managing pieces of hardware. We consume bandwidth in literally untold quantities. We have co-location with Yahoo, for example, in their data center in the Silicon Valley, and we use a vast quantity of bandwidth there. We also have co-location with the ISC, Internet Software Consortium, and elsewhere. The FreeBSD project set a number of records for bandwidth consumed by FTP servers in its early history, and we probably consume quite a significant amount still. FreeBSD doesn't happen for free. While many of the people who are involved in the project are volunteers and take a personal interest in the project, we also have a lot of people who are employed full-time by FreeBSD consumers to work on FreeBSD, from companies like Juniper and NetApp to the Yahoos and Verios of the world. There are a lot of people who are paid to work on FreeBSD, and that is part of what makes it so successful. And finally, we really like it when people tell us that they like us. We prefer not to receive flames. We do like it when people write about us in the media and say we're good people. And this is not unique to the FreeBSD project. I think it's fairly obvious that in the open source world, people thrive on reports of success and people using their software. There is nothing more satisfying than hearing from someone who uses your software and tells you how wonderful it is. And if they do tell you that there are problems, it's even nicer when they send patches. So let me tell you about some of our people and our processes. And again, these areas where you should be able to spot similarities and congruences with other open source projects. I mentioned to you FreeBSD committers. Well, committers are, in the most literal sense, people who can commit to the FreeBSD software repository. But there's a lot more to it than that. We actually don't give commit rights to arbitrary people. We don't just hand out commit bits on the street. We actually don't hand out commit bits to people who just submit patches even. We expect people who work on FreeBSD to be technically extremely competent, but also involved in the community. The point is that it's a community-developed piece of software, so you have to be able to work effectively in that community and communicate effectively. So there are a large number of people who produce patches against FreeBSD who aren't committers, not because we don't like them, but perhaps because they haven't yet figured out how best to work in the community, or they're still building a name for themselves in the community, and that community aspect is very important. When we participated for the first time in Google's Summer of Code program a few years ago, we observed something quite interesting about the way we structure our project and the way some of the other open source projects structure their projects. And that's that we have a mentorship program. We have a formal program by which we mentor new developers into the community. When a new committer is invited to join the project, they're typically invited by an existing developer, perhaps a couple of developers. And the commitment of that developer, their involvement in sponsoring a new developer in the project, goes on beyond the point where they get commit access. They become their mentor for a period of 3 months or 6 months, or in some cases, several years. And the point of a mentor isn't to help the person understand the technical aspects of FreeBSD, although code review is very important. It's actually to help them understand the social aspects, to help the new developer figure out what you should do and what you shouldn't do, what the expectations are, who you should talk to, what things are going to tread on people's toes, and what aren't. And this is very important to having a self-perpetuating community. You're passing on an understanding over time of the informal and social aspects of the project, and not just the technical aspects. It is not sufficient to turn up with good patches. There's a lot more to interacting with hundreds or thousands of people, largely via mailing lists. And obviously, mailing lists aren't the best vehicle for communicating. So the process for bringing a new member of the community is a potential mentor turns up with a potential committer. They go to the FreeBSD core team or one of its delegates, and I'll talk more about what that means. And then they basically ask them, can we bring this person on? And they create a proposal which describes the background of the person, their interests, what their contributions have been. And they're then evaluated by the core team or its delegates, who will usually vote in order to decide, can the member join the community? And then that developer who sponsored them becomes their mentor for the foreseeable future. So who are the committers that we have? I did a survey of committers in 2007 to see who was actually committing to the FreeBSD project. I found that we had developers in 34 countries, 6 continents. We have no full-time developers in Antarctica. We'd love to change that. If you live in Antarctica, you want to work on FreeBSD, do give us a call. They vary in ages. The FreeBSD project is quite an old project. Our mean age is 32 years. Quite a few open source projects have younger mean ages, I would guess. But often we find FreeBSD developers come to the project after they finish their undergraduate degree, maybe after they finished a master's degree or have worked for several years in industry. And I'll show you a graph that sort of talks a little bit more about that. But we have developers who are everyone from professional programmers to university professors. We have students, we have consultants, we have a range of people. And these developers often work with FreeBSD across several jobs. They take their skill set with them when they go to new companies. They tend to work at companies that use FreeBSD. They tend to try to teach other people to use FreeBSD. So there's sort of a commitment, a personal commitment to the project in most cases. And I think many of those FreeBSD developers have found that is quite good for their careers as well. It turns out there's a very high demand for FreeBSD kernel developers in the Bay Area, especially. Here's a map, show you where some of the clusters are. You notice that Europe is this big red blotch. There are a lot of FreeBSD developers in Europe. We think this is really great. We also obviously have a lot on the west coast of the US, or the east coast of the US. In India, we have a big community in Japan. Unfortunately, all the dots appear right on top of each other. But we have a lot of participants there, increasingly in China and in Australia. So we see FreeBSD in use in a lot of places. I'll show you this map again in a little bit with a few variations. I told you we're a sort of old project. We have a median and a mean sort of in their mid-30s. There was one bad year there. I'm not sure what happened there. Think about that one. We have a nice blip over here on the left end. This blip is actually a result of the Google Summer of Code program, which helps us to bring undergraduates into the community and in some cases younger than undergraduates in a way that otherwise we tend not to do. Usually people do come to FreeBSD a bit later and obviously stick with it. I think the tail end here you can see people who've been working on BSD for a rather long time. Something I haven't told you is that we have different kinds of committers that work on different aspects of the project. We don't just have developers in a generic sense. Many of the people who work on FreeBSD work on our base operating system. They work on the kernel, they work on the libraries, the command line tools, things like that. But we also have a very large community, ports community. These are people who adapt third-party software to run on FreeBSD. And as I'll tell you in a little bit, there are actually a lot more people to do it than these 163 people. These are the people who commit to the ports directly. We also have all these developers who submit changes as well. And we have a substantial documentation project. And there's some overlap between these. In fact, one of our most prolific SMP developers started off life working on documenting the kernel as opposed to using the kernel. So people do move around inside those groups. Talk about governance very briefly. Most open source projects do have some form of governance structure. Usually early in the life cycle of an open source project, it's the person who founded the project, or maybe a couple of people who founded the project. But the FreeBSD project has been going on for a long time, and not all the founders are actually working on FreeBSD still. In some cases, we've had people who worked on BSD at the University of California come back to the project and take on, in some cases, leadership roles, and in some cases not. Over time, the FreeBSD project moved from having a self-selected core team in which occasionally the leadership of the project would say, this person seems to be doing a lot, let's invite them onto the core team, to an elected model in which developers elect from among their number a small number of people to be involved in the administration of the project. Historically, core team meant these are the people who produce most of the code. And it's true today that people who are on the core team frequently do produce a lot of code because that's one of the ways in which they show their involvement in the project. And oftentimes developers will vote for people who produce a lot of code on the basis that this is one of the measures of confidence. If they produce really good code, surely they're good at running the project, or perhaps less so. So we moved gradually to this elected model. We also have a core secretary. Philip is our core secretary, who is actually responsible for making the core team work. When we came up with this model of an elected core team, we didn't actually assign it any responsibilities because it wasn't clear what the responsibilities of a core team were. The core team does officially approve new developers. But other than that, it has no official responsibilities. In practice, it actually does a lot of stuff. These tend to fall into a couple of areas. It tends to be involved in the daily administration of the project, the paperwork of the project, if you will, approving groups and official bodies inside the project to have particular rights or authority inside the project. We take a strategic role in trying to direct the project in as much as you can direct 340 volunteers and try to get them to all go in the same direction. That works with varying degrees of success. But also coordinating the project activities with other projects. We also are involved in the rules of the project. And I think every time you have a social institution that's sort of several hundred people or larger, you have to have rules. You can't just work informally all the time. We have rules about software maintainership. We have rules about review. We have rules that have to do with things like our release engineering process. One of our rules is that when we're in a release freeze, only the release engineering team can approve changes to the software repository. So the core team is involved in vetting some of those rules and helping to determine who gets to make rules and who follows rules, and once in a while, how you deal with people not following the rules. I do talk a little bit about conflict resolution later on. I think conflict resolution is a very important role for the FreeBSD core team to play. Anytime you have a large social structure, you have large numbers of people working together, there are inevitable conflicts, and those have to be resolved somehow. Ports committers, a little bit more about them. I told you that there were a lot of people who maintain software on FreeBSD. This is not part of the base operating system, but it's things that are very useful to have, like an X server. Life is somewhat boring without an X server or Apache. So we have a number of committers who are involved in maintaining a very large, essentially a database, if you will, of third-party applications and how to adapt them to FreeBSD. I took a look at our CVS repository last night, and I found that we had 250,000 files in revision control, of which maybe 190,000 of them were in the ports tree. So this is a very large project in and of itself, maintaining all these third-party applications running on FreeBSD. And sometimes this involves large patches. Sometimes the patches go back to the original software maintainers. I'd like to think it was most of the time. I suspect it's probably not most of the time. but it is a very substantial project. Each port has a maintainer. These people are not always committers. In fact, I guess only about 1 in 10 is actually a committer. So many of these changes are funneled through a small number of people into revision control. And that gives you a sense of the structure in which many people develop parts of FreeBSD and submit changes back, and then they get funneled into revision control, in part through a vetting process, but in part simply because we have people who work with a large number of ports or a large number of system components. People like org charts. I tried to draw an org chart for the FreeBSD project. It didn't really work. But if you look at this picture, there is an important difference between an org chart for a company and an org chart for an open source project, and especially a volunteer-driven open source project, since not all open source projects are volunteer-driven. In a classic org chart, the people at the top have all the power and all the money, and the people at the bottom, they're lucky if they get paid. And the money flows down, and the authority flows down because the people at the top say, yes, you should go do this. In an open source project, a volunteer project, this is not how it works at all. Authority flows up the stack. The people at the top get to make decisions, and their decisions get to stick because the people at the bottom of the project agree to go along with it. And this is part of this is having an elected core team where people delegate, as it were, the administrative right. But part of this is sort of implicit to the structure of a project. If you don't run the project in a reasonable way where people get listened to, then those people go away. So if you want to keep growing your community, you have to have a social structure that allows this to happen. And one of the results is this authority that goes up. So some of these teams and hats here, like our security officer, our release engineer and the release engineering team and so on, exist because there are activities that require more authority in the tree. For example, the ability to say, okay, nobody can commit anymore, or when somebody says nobody can commit anymore, certain people can commit or override, for example, maintainership. So our security officer and our release engineering team need these special rights. And the way they get them is that authority flows up the tree to the core team and then flows down the tree through a series of chartered organizations. And each of these organizations, or many of them anyway, submitted a charter to the core team that was then approved by the core team in order to structure their activities. We have a lot of these such organizations. Some of these are chartered and some aren't. I won't attempt to go through them all. I'll sort of pick out a couple of them. Everything from people who run our website to people who do testing, our summer of code mentors, people who mentor students participating in the project for summer projects. We have a lot of third-party projects we interact with who give us code. We give them back code. Code moves in both directions. People who do things like release engineering. A lot of people work on the project. It's too large a project for everyone to sit on one mailing list and do all the work. So we have a lot of mailing lists. So this is a somewhat complicated picture, but this is the simplified version. I tried to think about how does the FreeBSD project sit in this big open source ecosystem. I mean, obviously, we're interested in open source projects beyond just FreeBSD. You can write a whole operating system yourself, but occasionally it's nice to get some pieces from other people, like compiler suites. So where does FreeBSD fit in? Well, a lot of the original FreeBSD code came from Berkeley, and so we have a big line there. We also generate code that a lot of other people use. For example, Mac OS X's Darwin operating system includes a lot of FreeBSD code, significant parts of the kernel, a lot of user-based libraries, and so on. We have other projects that are purely open source, spin-off of FreeBSD, such as PCBSD, who take FreeBSD releases and bundle them up with a neat packaging tool, provide nice user interface parts, and so on. There's a talk on PCBSD later I encourage you to attend. And we also have people who take it and stick it in sort of more appliance-like structures like pfSense. And this isn't unique to the open source world. This is also closed source. We rely a lot on the Free Software Foundation's compiler chain, for example. Code also moves back and forth between us and Open Solaris. We recently picked up ZFS. So FreeBSD 7.0, which is coming out shortly, supports ZFS out of the box, which is very nice. And some code even moves back and forth with the Linux kernel. So we see a lot of code move around. We also have OpenBSD and NetBSD, which are also spin-offs off of original Berkeley code. A lot of code moves there as well. And obviously, yeah, lots of lines, I guess. So this is kind of the open source operating system picture. And if you layer stuff on top of it, FreeBSD isn't just a target itself. It's also a platform for a lot of other work. Then the picture will be even bigger. You fit Xorg into it. I said we do a lot of work on mailing lists. We have over 100 active mailing lists. And this is where the bulk of the work of the project happens. We try to get together in person sometimes, but many things are done online. On the whole, these are intentionally public mailing lists. They're places where anyone can participate who wants to, from the user community to people who submit patches, or people who work on other operating systems turn up on our lists and discuss things with us, which I think is actually really great. We do have a few private lists. For example, our security officer mailing list. We are in essence, a public organization, but there are times when you need to have private conversations. So undisclosed vulnerabilities are certainly one case, but another one is conflict resolution. It's really hard to get two people who vehemently disagree with each other to agree in public. First, you have to kind of get them to talk to each other a little bit in private, maybe kind of find some common ground and consensus. Maybe, maybe somebody was wrong after all. Try doing that on a public mailing list where 100 people will join the conversation. Very bad idea. So private mailing lists do play an important role in the project. I said we had a web presence. Well, we do. We have a lot of websites. I think we've been a little slow in picking up the forum, the sort of web forum approach to communications. We're very much sort of caught in this world of mailing lists, but I think we're gradually beginning to have some impact there. Some of our spin-off projects, such as PCBSD, do make effective use of web forums. I think I would claim the FreeBSD project itself doesn't yet do that. Of course, the FreeBSD project grew up with the web, and in fact is used to host a great many websites. So we do try to get together. We participate in conferences. I should add FOSDEM to the list of conferences we participate in. The most recent new BSD conference, there seems to be a new one happening every year, is BSDCon Turkey. We had the first one in October of last year in Istanbul. We also have developer summits, which are sort of intended just for the developer community, and they coincide with these conferences since you have everyone in the same place at the same time anyway. Our big developer summit every year is BSDCan, which occurs in May in Ottawa, Canada. But we also have them scattered around the world. And these can be anything from 10 developers in a room to 60 developers in a room sitting around talking to each other and hacking code and doing all those other things that developers do. It does involve occasionally going out to eat and things like that. This is Pavel, by the way, with his ZFS presentation last year. He observed that it uses a lot of memory. Here are the kinds of things we talk about at these developer summits. They are pretty intensely technical events, although they obviously have a social aspect. And I think it's interesting to look down this list because you'll see that not only do we write a lot of code, for example, security frameworks, ports to new architectures, things like support for virtual access points in 802.11, multi-threaded network stacks and all that kind of thing, but we also bring in code from other places. For example, support for Zen, dtrace coming in from OpenSolaris. We've been working very closely with Coverity for a number of years. They help us run static analysis. We are, I think, the only open source project making use of the extend tool, not just the prevent tool. Extend is an extensible software analysis tool for static analysis. You can create your own invariants and test them. So we had Coverity out at our developer summit last year in May doing training for developers who wanted to learn how to use extend. I'll talk briefly about the development model, and I think this will look familiar to people who work in open source software. We have a development head where the majority of the really disruptive work takes place. And every now and then, we spin off branches, which are what we actually cut releases off of. So FreeBSD does major releases and minor releases. We do major releases maybe every 18 to 24 months. Occasionally, it's a bit longer. Our FreeBSD 5 release took a really long time, but the last few have been a lot quicker, in part because we've tried to move to a time-based release schedule. When we're ready to do a new major release, we spin off a branch, and then all the minor releases come off of that. But we also create branches for each individual release. These are where our security patches live, errata and so on, things where we fix critical bugs after the software has been released and provide binary updates. It's all done in revision control. We have this notion of something called an MFC. There are two ways that major new features end up in a FreeBSD release. They can start out in the head and then get spun off at some point into a particular branch that will first appear in a .0 release. Or there can be this merge from current, where a change is brought back from the head of the tree into a particular branch when it's considered to be mature. This means that really major features, which you can't just merge because they're complicated and they have interactions, are guaranteed eventually to hit a major release, a .0 release. But minor features can be moved back and are, for example, lots of driver changes, new file systems, things like that. Things where you're not disrupting the infrastructure of the software, but you're plugging neatly into sort of compartments and spots where you can plug things in. New storage transforms are easy to merge, versus fundamental changes in the network stack and memory allocators are very difficult to merge. FreeBSD 7.0 is coming out really soon. Ideally, maybe next week, the week after. I hear they're building releases now. We have all kinds of cool stuff. We spent a lot of time working on multiprocessor scalability. It's quite exciting news. The new malloc that we have, a highly scalable malloc, has recently been picked up by the Firefox project. They plan to use our malloc on other operating systems than just FreeBSD because it works particularly well with respect to memory fragmentation. I was very excited to hear about this. But we have a lot of other things going on, fine-grained locking the kernel, new schedulers, threading libraries. File systems, we picked up the ZFS file system. I think this is a good example of us being able to pull in software from other operating systems and make effective use of it. We also see code move in the other direction. I believe OpenSolaris now uses our 802.11 stack. Fun stuff going on in networking. I mentioned the SCTP reference implementation, but we've also been doing a lot of work with 10 gigabits optimization. Chris Genoway has a talk he gives on FreeBSD 7.0 in the BSD and Postgres track, and I would encourage you to take a look at that. It sounds pretty exciting. I want to talk a little bit more about revision control. I said revision control is kind of the heart and mind of the project. This is where everything real goes. All authoritative project activity is in CVS. Our software, our web pages, it's all managed in revision control. We ran into a problem, though, which is that CVS, excellent piece of software, doesn't quite scale the way our software development practices do. We actually have 4 CVS repositories now. And as I mentioned earlier, 250,000 files across all of them. We do run into the limitations of CVS on a regular basis, and I'll talk to you more about that in a second. What's quite neat is having a 10-year revision history right there, so you can do CVS log and CVS diff and go back and see why things happened the way they did. And now that a lot of lawsuits and other things have been resolved, we're quite pleased that the original CSRG history of BSD development is now also available. So you can actually go back and look at the original development of some of these pieces of software in the 1980s, which is quite exciting. We also use Perforce. So I said authoritative work happens in CVS. Well, CVS doesn't scale in a number of ways. In particular, it's really hard to branch a source tree that has 100,000 files in it, because in CVS, that is a linear time operation on the number of files. So you have to go through and you have to touch every file in the CVS repository. So we try really hard not to branch and not to tag. We do it for releases and basically for nothing else. Perforce gives us a sandbox with very lightweight branching, where developers can log in and create as many branches as they want to, well, within reason, over time, and then use it as a place where they can collaborate. It also gives us a place where we can have guest accounts, because it has very fine-grained access control. So we've used Perforce for a lot of project development on the side. Everything from our SMP support to new security features, support for super pages. All of our Summer of Code students are set up with sandboxes inside our Perforce repository so that they can branch from the main FreeBSD CVS tree into Perforce and then do their work there and expose it more in the community. Recent work includes ZFS, support for AFS, and things like that. So it's where a lot of the active development happens. This has led to an interesting change in the way that we use CVS. So in CVS, because branching was very expensive to the point of not really being possible, we found that our development head was very unstable over time. It meant that when you brought in one unstable feature and you sort of waited for it to stabilize a bit, but then another unstable feature came in. And if you wait too long between releases, you don't take a break every now and then, you reach a point of instability where the code you have is actually not very usable, which puts all the people who are using the current branch at risk of not being able to make progress on development. What Perforce lets us do by having heavily branched development, and I trust I'm preaching to the choir in this sense, is allowing you to isolate high-risk development and merge it in a sensible way back into the main tree. And as I understand it, Perforce was first used with FreeBSD as part of the CAM SCSI project, where the work was done independently and then brought in to replace the existing SCSI layer. And we now use this, I think, pretty much for everything. So here's a simplified picture. The FreeBSD current branch runs along the center, and what we see is code flowing out into Perforce branches and then flowing back. And sometimes there are Perforce branches off Perforce branches. For example, we have a trusted BSD project, which has many other projects hung off of it. And in fact, we have an SEBSD project, which has a port of Flask and type enforcement from SE Linux to run on FreeBSD, is branched off of our Mac work, which is off of our trusted BSD work, off of our current branch. So there's a lot of sort of depth to this development model. I think in some ways, I mean, Perforce is an excellent piece of software. It really works very well. But the use of Perforce is really a symptom of a problem we have with CVS. And that's that CVS is an excellent piece of revision control system written a long time ago. It doesn't have all sorts of things that we now expect from a modern revision control system, starting with change sets, but also things like lightweight merging, three-way merging, history-aware merging. When you're maintaining a long work in progress, something that takes years to develop, CVS is not the tool for you if you're tracking someone else's code, because it provides you with no automated tools to merge the changes made by a third party. Every few years, we kind of look at what the options look like. So far, we've not found something that would work for us. There are a number of features that are missing from revision control systems, and perhaps people in the audience who work on revision control systems would love to take a look at this. We would love to be able to move back to one revision control system that does everything we need. But we particularly run into problems with scaling and the need for obliteration. Obliteration is an interesting point. I sometimes have conversations with revision control people who say, the point of a revision control system is that it never loses anything you've ever done. And there are times when you want to lose things that you've done. Those times include lawyers, where they come to you with letters, and the letters say, you're infringing our trademark. You must cease all distribution of the following thing. for example, Boggle, which appeared in the BSD source tree coming out of Berkeley and was later removed from FreeBSD. If it's in your revision control system, you are still distributing it. You are still giving it to other people because they could check out the previous version. Therefore, you are infringing. So you must be able to remove something and all of its history from the revision control system. This is a practical requirement, must be met by a revision control system. CVS doesn't do it, but we can make it do it. Perforce explicitly supports it, but many of the next generation revision control systems don't support obliteration by design. They include cryptographic hashes that link previous revisions to the next revision. Right now, most of those tools don't include a way to go back and put a little annotation with a signature that says something like, there were some changes here, but they're gone now, that's okay. And that's really all we need. It has to be best effort. We don't have to, doesn't have to be perfect, but we need something that does kind of what the lawyers ask for when they ask for it. And there are other reasons than lawyers, but lawyers are a particularly motivating reason if you run a large open source project and are on the board of their foundation. Move on from revision control. I told you we have clusters scattered around the world. I guess we really have sort of 5 main sites at this point, although obviously there's lots of other stuff going on. Most of these places are places that consume FreeBSD. For example, ISC uses FreeBSD on root name servers and other sorts of name servers. Yahoo makes extensive use of FreeBSD. Yahoo is where we host most of the project infrastructure. Our CVS repositories, we have a NetApp filer, we have all sorts of stuff going on there. We have a NetPerf cluster and security development cluster. This is where we prepare security advisories, we do binary update builds, things like that. We also do 10 gigabits network optimization. We have an FTP server in Denmark, and then in Japan, we have hosting of large-scale SMP systems. One of the things we're in the process of doing is exploring providing failover from the FreeBSD.org cluster at Yahoo to our Centex cluster. I don't mean failover of all active services, but we want an off-site backup at all times because things happen like earthquakes, and we'd rather not be susceptible to that. And as a large organization, we have to think about things like disaster recovery, the sorts of things that companies often have to deal with because they have very large infrastructures. Our developers are neatly scattered around the world, but a lot of our electronic resources are in a very small number of places, so we need to try and manage that risk. Last thing I'm going to talk to you about is conflict resolution. I mentioned this is a hard issue. So in a large open source community, inevitably there are people who disagree with each other. And one of the neat things about open source developers is that they're very independent-minded. They like to go off and do things the right way, and sometimes they disagree on what the right way is. Sometimes these are technical disagreements, and technical disagreements are actually fairly easy to resolve. They're the kind of disagreements where you're not quite sure, is this the right way to do it, is that the right way to do it, and somebody can turn up and mediate. They can say, well, they both have their merits, but maybe this one is more in our interest in the long term, or can we take elements of both of these and combine them? Those are the easy ones. The hard ones are personality conflicts or communication conflicts. I said we had people in, I think, 34 countries around the world. Not all of them speak the same language. This is shocking news. And obviously, communications issues are one of the major issues. It's very easy when you're a non-native speaker of a language to say things that come across as brusque. And sometimes you're saying them brusquely in your own language. But sometimes they just come across as brusque. And those are actually really hard to deal with if you have two non-native speakers of a language communicating in that non-native language in order to try and reach an agreement. Sometimes these personality disagreements can't be resolved, and people go their respective ways. Sometimes people leave the project because they can't get along with the people who are there. Maybe this is a good thing, because the people who are left apparently can get along. And getting along is really important when you have a large project. But often as not, these things can be resolved, but it requires personal intervention of someone in the project. It requires someone on the core team to sit down with the two participants in the disagreement, talk to each of them independently, and then try to get them talking to each other and figure out what's going wrong. Because often as not, there are disagreements that can be gotten over. A fundamental misunderstanding early on led to problems. And they can't always be resolved, but mediation is an important thing that the FreeBSD project's core team gets involved in. Okay. So what I've done is I've tried to give you an introduction to the structure of the FreeBSD project, but in a way that sort of it might have explained some aspects of other open source projects. And there are going to be similarities and differences. This was not a software talk, but obviously we're interested in software. I think FreeBSD is one of the most successful open source projects out there. I don't think I would make any claim it's the most successful open source project. And I'm not sure how you would measure success in a really sort of concrete sense, other than to say that having a large deployed user base, having an active and sustainable community that is growing over time, that has new people joining on it, and has a model for growing over time, is an important way to define success in open source. It's not just about having good code. I mean, I think we do have good code. Maybe that's a personal perspective, but people wouldn't come to the project if they didn't like the code. But it is not just about code. There's a lot more to it. So I guess I would invite you to take a look at FreeBSD if you hadn't, and consider participating in our project. But I guess it would also be interesting to hear from people in the audience who have open source projects they run or are involved in whose models differ from FreeBSD and why that is. I think FreeBSD model works very well, and we've seen some other projects pick up that model, especially things like mentorship, which I think is a really good thing. And I think programs like Google Summer of Code program have forced projects to adopt a mentorship approach. And I think that's part of what you need to have a sustainable open source project. Guys, thank you very much. I'm happy to take questions for a few minutes. And I think we have a microphone if anyone wants to ask questions.
Hi. What were your measurements to assure the independence of the project?
I'm sorry, I'm having a little trouble hearing you.
So what were the measurements that FreeBSD core developers and the foundation have taken to assure the independence of the project?
Yeah, that's an interesting question. Because a lot of our development is sponsored by corporate sponsors, there is a constant question of how do you maintain a difference between the open source project and the people who do the work on the project who are doing it for corporate purposes. And we've had, I think it would be accurate to say, an active debate on how you deal with corporate sponsored work especially. Do people have a right to bring things in because they were paid to do it but may not maintain it in the long term? And I think there's a constant tension there. Having a foundation is an important way to maintain independence because it gives us our own legal entity. Likewise, I showed you the map of clusters around the world. Making sure we have redundancy over time, that we're not all in one place, is a very important aspect of making sure the project is preserved. We also take other legal steps, making sure we review new licenses as they come into the tree, and so on. And I think those are all part of the picture. But if you look at the FreeBSD developer community, often as not, people are much more loyal to the project than they are to their current employer, which from an open source perspective, I think is a very good thing.
Okay, thank you.
Any other questions? Sorry, I'm having a little trouble hearing. Quiet, please. Yeah.
What steps has the FreeBSD project taken to try and ensure whole community cohesion? Because after a project gets above a certain size, it's difficult to have everybody on the one mailing list. And without communication with everybody, it's hard to have a single community. Do you just find that it ends up in lots of small communities which collaborate sporadically, or have you been able to try and hold together that whole project sense? And if so, how have you done it?
I think that's actually a really fascinating question and a really fascinating problem. And I think we've struggled a little bit to try and figure out how to address that. In particular, I think it's important to get people together outside of the mailing list in order to build that sense of community. And that's part of why conferences are so important. And a lot of the FreeBSD Foundation budget goes towards paying to fly FreeBSD developers to workshops and conferences so they can meet in the same place. We do have a single mailing list that has all FreeBSD developers on it. But obviously, when you have an audience of 400 people, you can't talk about everything on it. So we try to discourage people from talking about things that are potentially public on a private mailing list. There are a few mailing lists which do have a lot of subscribers. The FreeBSD current mailing list, I think, gets most source developers on it. And then, for example, the ports mailing list gets most ports developers. I think I'd say we do struggle a little bit to try and solve that problem, and we do have communities that become independent, and sometimes that results in conflicts. But the role of the core team is to try and spot those in advance. And one of the techniques we use is once we have an elected core team, we try to make sure that core team members are involved in each one of the independent projects in as much as possible. And that way, the release engineering team, for example, I'm on the release engineering team and I'm on the core team. And we'd like to think that that makes communications a little bit better between those compartments.
Can everyone sit quietly for another 5 minutes, because it's very difficult for questions and answers to get across. So if you're moving, tiptoes, really quietly, 5 minutes roughly-ish.
Yeah, Philip can be very threatening when he tries.
Extremely threatening. That's why I'm core team secretary.
Yaha. Yes. I'm sorry, I can't.
Can you hear me now?
Yes, I can.
Thank you.
Oh, now I lost you again. I can only hear you when you say, "Can you hear me now?"
Hello? Oh,
Hello.
that's great. I'm working for a company named G.ho.st. It's a virtual computer on the web. You can access it. This is actually our URL also. And currently our source is all closed. And the reason I'm here is to learn how to make it open. We'd like to take several practical steps to open the entire source. We will start with something. And you have extensive experience, so I would like to take your advice. What would you advise as a first practical step to take?
The foundation works with a lot of companies who use FreeBSD, and I listed some of the companies that do use FreeBSD on the first slide. Not all those companies have an easy relationship with FreeBSD. We found that a lot of people who built products on FreeBSD, maybe the FreeBSD 3, 4.0 time ranges, had a lot of trouble getting forward to our FreeBSD 6 development branch. There was a period of moderate instability about when the .com crash happened. A lot of FreeBSD developers who've been working full-time on FreeBSD had to go work on other stuff. They lost their jobs. Sometimes that helped FreeBSD, but more often than not, it hurt FreeBSD. And as a result, our FreeBSD 5 development process really stretched out for a long time. There was a long period of instability before we sort of got back to the point where we were saying, okay, now the FreeBSD 5 branch is ready to use. So we had a lot of users who were stuck on FreeBSD 4. And in the last year or two, many of them have now been getting forward to FreeBSD 6 for their products. And they found that was very difficult because, of course, 5 years had passed. It's amazing how much code in an operating system can change in 5 years. The architectures we developed for have changed fundamentally in 5 years. Multiprocessing is now an embedded feature, right, as opposed to a feature for supercomputers. And so suddenly all these embedded companies need to run on many core ARM processors or MIPS processors or whatever. The biggest advice we gave to those companies was get involved in the community before you try to give back your changes. Because having the social link to the community, having a reputation in the community, is what helps you get the changes back in. You have to enter the community with credibility. The other piece of advice is that there is a long-term payoff for bringing your changes back, even though it takes a long time and it's expensive. It is not free to open source a piece of software. Companies that open source their software have to consider intellectual property aspects. They have to consider the developer time spent to isolate the changes they do want to open source from the ones that they don't. They have to figure out how to work with the community. That is difficult. If you are open sourcing a piece of software that has never been open source before, it isn't tied to an existing community, I think that's really challenging to do because you have to create not just the open source software, but the open source community. So your best bet may be to find other communities of similar interest where you can find a spot in that community. And that will help get people involved and interested in your software. If you're contributing back changes to an existing piece of open source software, and this applies to FreeBSD or anything else under any license, that community participation is critical. Because otherwise you end up creating a tarball, putting it on your website and saying it's open source. And that is not the same thing if you want it to be sustainable. Dumping a tarball on the web page means nobody will use the software. Whereas helping to get your changes integrated back into whatever is upstream, whatever that may mean, is a good way to get people involved. Some of the companies that work with FreeBSD, I think Yahoo is a particularly good example of this, make it part of their technical development model to merge changes back to FreeBSD to avoid divergence. Other companies, especially the ones jumping forward to 6, have recently become aware that it's very important to do this, because otherwise you end up 4 or 5 years behind with heavy customizations that really weren't part of your core product. They were just things you had to do anyway. And if you got those back into the base OS, then your workload would get much lighter to maintain. So I think there's a long-term benefit there for companies to do that. But often they have to make a short-term investment that's quite large, which means paying your developers to sit on mailing lists and answer other people's questions about other people's software, which is sort of counterintuitive from a short-term business perspective. That's hard to justify up the line. So anyway, I hope that's helpful.
Can you hear me?
Yeah.
Can you provide some advice to open source projects on contingency planning? Say if Microsoft were to make a hostile bid for a large number of your developers and apparently some hosted servers? Do you plan for that in advance?
Yeah. So I guess if you work for a company that does open source stuff and you discover that you may be about to be acquired by a large company that doesn't do open source stuff, the first thing I'd say is take a deep breath, because sometimes open source makes money, right? Sometimes open source is the right way to do something. And if the company that is acquiring you may not have a problem with your doing open source, obviously it's very important to have the paperwork in place. as your company is about to be acquired, make sure you've actually already open sourced all the things that you plan to, all the T's are crossed, all the I's are dotted. Make sure copyright assignments are taken well into hand. One of the things I encourage companies to do that work with FreeBSD is to be very, very clear on what they're doing with copyright and what they're doing with licensing. Make sure their lawyers know what's going on. Make sure that there are signed pieces of paper in the hands of their employees saying, this is what I want you to do. It can be an email, that's even fine. But it has to be explicit communication saying from somebody who is in charge to somebody who is doing the work, yes, I want you to do this. Don't assume that just because the management stack today is friendly that they won't be tomorrow, that they will be tomorrow. Make sure all the paperwork is ready. But at the same time, I wouldn't worry too much. I think there is a business argument to be made for being involved in open source. And at the end of the day, it comes down to a business decision. And if you can make an argument that open source makes your business run better, then you may well find that you thrive at a company that has never done open source before. And I think that the open source revolution in the last 5 or 10 years has come about because companies who didn't realize they were using open source discovered that it works really well and that it works better if they participate in those communities. So I wouldn't give up hope.
Shut your servers off. Can you hear me?
Yes.
What if Microsoft decides to take the servers offline that your project sort of depends on, it seems?
Well, there's only so much you can do if somebody else holds the power cable and pulls it out. If you're an open source project that depends on the resources of that company, then I would advise the open source project to have contingency plans. And I think any scalable open source project should consider contingency plans in just the same way any scalable company does. When you're a small company with 2 or 3 people, and there's an earthquake, your company goes out of business and that's life, right? You're a couple of people in an office and the office disappears, then your business is in trouble. Nothing you can do is going to change that. But if you are a large-scale open source project with hundreds of developers around the world, and you are seriously at risk that your single host is going to go away, then the obvious strategy is to find more hosts and to make sure you have plans to deal with it. And I think the FreeBSD project is not alone in making contingency plans, and I hope that other open source projects who maybe don't have them today take it into account. One of the things that we are in the process of formally doing, and with something we've been working on for a while, is coming up with formal contingency plans, not just okay, we dump the servers in the back of the truck and we drive over to the other place, but we have backup servers, we have sites that have guaranteed that they'll make the bandwidth available, we know that these are reliable places, we have data retained offsite. One of the things about our development model, and I mentioned 2 revision control systems we use, we actually use 2.5 revision control systems. We also use something called CVSUP, which mirrors CVS repositories. We use it to get scalability so that if you have 100 developers all hitting CVS at once or 1,000, read access doesn't crowd out write access. We replicate our source code repository. There must be thousands or millions of copies of it around the world. And there's nothing quite like having 1,000 copies of your CVS repository scattered around the world for some data reliability. I suspect we're running out of time. Do we have time for any more questions, or are we done? We're all done. Great. Well, thank you very much.
Microphone here somewhere.
That one went away.